What answer did you come up with, David?
So at the top, I put right triangle because we actually defined axiomatic concepts as things that can be defined mathematically with necessary and sufficient conditions, and right triangle seems like a very emblematic example of that. Reptile I also put close to the top because in the biological definition, there are necessary and sufficient conditions for being a reptile. They may differ a little bit from the way you and I think of reptiles, so we might have more of a prototype concept of reptiles, but in biology, there is a very formal definition of what a reptile is. With foo, we kind of built our understanding based on different examples, so we had kind of a prototype view of foo. And similarly with holiday, you can think of examples of holiday. You don't really have a definition that something has to meet to be a holiday, but you can think of holidays as sometimes being a day that you get the day off. It's sometimes a day that's a particular day of the week or a particular date of the month. So there are different things that are overridable about different holidays. Inspirational is something that's a little bit hard to define what makes something inspirational, but you and I can very easily come up with some examples of some things that are inspirational, such as watching someone win in the Olympics or listening to a moving rendition of the national anthem. Those are two different things that are very, very different, but have the same kind of underlying concept behind them. And then saltiness reflects what you were saying earlier, Ashok, about tastes that can be very difficult to describe to another person.
So part of the point of looking at these different kind of concepts is that depending on the different kind of concept we are dealing with right now, we may come up with a different knowledge representation and a different inference method. Let me explain. Supposing we're dealing with concepts like foo or holiday or inspirational, then the case-based reasoning method might be a very good method for dealing with things of that kind. We may have experience with specific holidays, but we cannot abstract them out into a concept with prototypical conditions. On the other hand, if we were dealing with concepts like a right triangle or a reptile for which we can define necessary and sufficient conditions, in that case, there are alternative methods available that might be more suitable than case-based reasoning. So instead of thinking in terms of one method that is going to work for all conditions and all concepts, we might want to think in terms of an array of methods where each method is more or less useful for different kind of conditions or different kind of concepts. David, I'm sure you recall Mendeleev, who was a Russian chemist who came up with the basic notion of the chemical periodic table. I'm sure all the students in the class know about the chemical periodic table, which organizes all the elements according to certain properties like hydrogen, oxygen, calcium, and so on. Now, Mendeleev came up with this notion of a chemical periodic table. In some sense, what we are trying to do in this course is to build a similar kind of periodic table, except that this is a periodic table of the elements of mind. It's a periodic table of the basic fundamental elements that compose intelligence. Instead of talking about elements and valencies and atoms and so on, what we're going to be talking about are methods and representations. So it is as if we are discovering the fundamental knowledge representations and organizations and reasoning methods that go with it. Case-based reasoning was one reasoning method that went with certain kinds of concepts that are hard to abstract into conditions like typical conditions or necessary and logical conditions.